Hi, I am Raghavan, chemistry faculty from Alfords College. I welcome you all for Alfords Chemistry e-learning program session 25th. Okay, in the last session we had some numericals we have done, that is based on de Broglie's theory and Heisenberg uncertainty principles. Okay, we completed the numerical part. Okay, in the previous session we have done the theory part, that is the derivations, and yesterday, that is in the last session we have done the numericals on de Broglie's and Heisenberg, both are completed, right? Now in this 25th session, let us discuss today about quantum numbers, that is quantum numbers. What are quantum numbers and what is the significance of quantum numbers? Yes, in the universe, we can give identity, that means address any particular object, okay? For example, address of a particular person, name of the person, son of, house number, area, nearby location, okay, and the town, mandal and taluka, district, and with the help of the pin code. So if you drop any letter in anywhere, so with that pin code, with that particular address, so it will reach to that particular person. Okay, that means we can give address of any person or any object in the universe. Remember, to identify the address of a particular object, to identify the nature of a particular object, we can give address. In short, we are saying that nature means we are giving address to that. Okay, nature of a person, that means address of a person. In that way we have to understand, right? Now similarly, for example, let us take neon atomic number 10. It has 10 electrons. I want to know the nature of a particular, that is seventh electron. So that is to describe the nature of the seventh electron, that means to identify the nature means what? Address of seventh electron. What do you mean by address of the seventh electron? That is size, that means where, in which orbit it is present, in which subshell it is present, in which orbital it is present, and what is the spin of that electron. Okay, that is called to describe the nature of electron. Okay, to describe the nature of an electron, I'll write. So what is the significance of quantum numbers? To describe, yes, to describe the nature of an electron, to describe the nature of an electron, to describe the nature of an electron. Sir, what is the meaning of nature of electron? That we can say like this, that is size, energy, shape, orientation, and spin of electron. To describe the nature of an electron, what is the meaning of nature of an electron? To explain size, energy, shape, orientation and spin of the electron. The 4 quantum numbers are required. What are the 4 quantum numbers? That is principal quantum number, number 2 is azimuthal quantum number. Number 3 is magnetic quantum number. Number 4 is spin quantum number. Okay, once again, how to start introduction to the quantum numbers? To describe the nature of an electron in an atom, To describe the nature of an electron in an atom, see for example, sodium atomic number is 11. So to describe 11th electron, okay, you can describe 11th electron in which orbit it is present, in which subshell it is present, okay. To describe the nature of an electron, to describe the nature of a particular electron in the atom, the 4 quantum numbers are significant. What are the 4 quantum numbers? Principal quantum number, azimuthal quantum number, magnetic quantum number and spin quantum number, okay. You got it, I think it is clear. Introduction to the quantum numbers, okay. So what is the significance of all the 4 quantum numbers? Very simple. To describe the nature of an electron, to describe the nature of an electron in the atom, so 4 quantum numbers are significant. Yes, what are the 4 quantum numbers? Principal quantum number, azimuthal quantum number, magnetic quantum number and spin quantum number, okay, right. That is introduction to the quantum numbers. Let us take up one by one, okay. First one is principal quantum number, okay. First one is principal quantum number, right? Yes, principal quantum number. Principal quantum number was explained by the scientist Niels Bohr. Principal quantum number was explained by Niels Bohr. First one is principal quantum number, okay. Remember, principal quantum number, or it is also called Bohr's quantum number, or it is also called radial quantum number, okay. Principal quantum number, principal quantum number, okay. Principal quantum number, or it is also called radial quantum number, okay. Radial momentum quantum number. Whereas azimuthal quantum number is called angular momentum quantum number, okay. It is radial momentum quantum number, right. Principal quantum number was explained by, or you can say discovered by Niels Bohr. Discovered by or introduced by. Principal quantum number was introduced by Niels Bohr, okay, or it is explained by Niels Bohr, right. Principal quantum number represents, principal quantum number represents the circular orbit revolving, that is circular orbit. Principal quantum number represents the orbit, the circular orbit. It represents circular orbit. It represents circular orbit in which electron revolves around the nucleus. In which electron revolves around the nucleus. What does principal quantum number represents? Principal quantum number represents circular orbit in which electron revolves around the nucleus. In which electron revolves around the nucleus. This is orbit, means, yes. Now, principal quantum number means it is nothing but orbit, okay. So the entire Bohr's theory, it explains only the nature of the orbit, okay. Entire Bohr's theory is nothing but our principal quantum number, okay. Exactly, the entire, because entire Bohr's theory is representing only the orbit it describes, okay. Now, principal quantum number means the circular orbit, electron revolving around the nucleus, that is principal quantum number, okay. It is, orbit is denoted by the symbol n. Orbit is denoted by the symbol n. Next, number of orbits are designated as, 1, 2, 3, 4, 5, so on, are K, L, M, N, O, P, Q, shells, okay. That is not small letters, it should be capital letters, okay. So there is no specific reason in selecting these letters. Remember that point, okay? There is no specific reason in selecting these K, L, M, N, O, P, Q shells, okay? So once again, principal quantum number was explained by Niels Bohr. Principal quantum number represents the circular path, that is circular orbit, in which electron revolves around the nucleus. The orbit is denoted by the symbol N. Orbit is denoted by N, means circular orbit, right? The number of circular orbits, that is N orbits, are designated as 1, 2, 3, 4, 5, 6, 7, so on, or K, L, M, N, O, P, Q, so on. There is no specific reason in selecting these special K, L, M, N letters, okay? As long as electron is revolving in the circular orbit, it neither loses nor gains energy. As long as electron is revolving in the circular orbit, it neither loses nor gains energy. It means each orbit is associated with definite amount of energy. Or you can say, when electron is revolving in the circular orbit, the energy of the electron remains constant. Energy of the electron remains constant. Therefore, orbit is also called stationary orbit or stationary state. Stationary orbit or stationary state, or you can say energy level, stationary state or stationary level, or you can say energy level, right? So principal quantum number means it is orbit. Principal quantum number means orbit or stationary state or energy level or stationary level, right? Stationary state, because energy of the electron in the orbit remains constant, okay? Next, when electron is revolving in the circular orbit, the angular momentum of the electron in the orbit is quantized. The angular momentum of electron revolving around the nucleus in the orbit is quantized. That is, mvr is equals to nh by 2 pi. Angular momentum of the electron revolving in the orbit is quantized. mvr is equals to integral multiples of h by 2 pi, where n is the integer 1, 2, 3, so on, integer, okay? That is concerned with angular momentum of the electron revolving in the orbit, okay? Next point, as the number of orbits increases, like say this is the nucleus, we have first orbit and second orbit, third orbit, like fourth orbit and fifth orbit, like that. As the number of orbits increases, this is size of the first orbit, second orbit, third orbit, fourth orbit. As the number of orbits increases, the size, radius of the orbit increases. That means size increases as number of orbits increases. As number of orbits increases, size means radius increases. Radius of the first orbit, that is radius of the first orbit is r1. Say it is r1. Radius of the first orbit is r1. So radius of first orbit. Radius of second orbit is r2. Radius of third orbit is r3. Radius of fourth orbit is r4. What is the relation between them? Sir, radius of the first orbit is less than second orbit. Second orbit radius less than third orbit. Third orbit radius less than fourth orbit. That means as the number of orbits increases, the radius of the orbit increases. Means the size of the orbit increases. Okay, size of the orbit increases, and energy of the orbit, rather you can say energy of electron also increases. Energy also increases. That means energy of the first orbit, say it is E1, second orbit E2, third orbit E3, fourth orbit E4. That means energy of the first orbit E1 less than second orbit E2, less than third orbit E3, less than fourth orbit E4. That means size, radius increases and energy of the electron, means energy of the orbit also increases. Okay, energy of electron is nothing but energy of the orbit only. Okay, because energy of the electron in the orbit remains constant. Okay, so therefore energy of electron means it is nothing but energy of orbit, right? So as the number of orbits increases, size increases, energy also increases. Energy also increases. Yes, energy increases. Okay, but energy difference between successive orbits decreases. Energy difference between successive orbits gradually decreases. That means energy difference between E2, E1 is greater than E3 minus E2. It is greater than E4 minus E3. Okay, E1, E2, that is the difference between the first two energy levels is greater than second and third. It is greater than third and fourth. That means, once again, let me explain the point. As the number of orbits increases, size of the orbit increases, or size of the atom increases, radius of the orbit increases, and energy also increases, but energy difference between successive orbits decreases. Got it? And velocity of the electron also decreases. As the number of orbits increases, velocity of the electron also decreases. That means velocity of the electron in the first orbit is very high compared to the second orbit. So that means velocity of the electron in the first orbit is greater than velocity of the electron in the second orbit. It is greater than velocity of the electron in the third orbit. Okay, that means as the number of orbits increases, size increases, that means radius increases, and energy also increases, but energy difference between successive orbits decreases, and the velocity of the electron also decreases. Okay, so this is completely up to this. Next, Niels Bohr proposed equation to calculate radius, to calculate energy of electron in the orbit. Okay, next, Bohr equation to calculate radius and energy of the electron in orbit. Okay, once again let us refer from the beginning. Okay, principal quantum number represents, not significance, represents the circular path, that is circular orbit in which electron revolves around the nucleus. It is denoted by, that means orbit is denoted by the symbol n. Orbit is represented by n. Okay, the number of orbits are designated as, this is 1, 2, 3, 4, goes on like this, R, K, L, M, N. Okay, number of orbits are designated like this. Next, we have to describe orbit is stationary. How you can explain that? As long as electron is revolving in the circular orbit, it neither loses energy nor gains energy. It means when electron is revolving in the circular orbit, the energy of the electron in the orbit is constant. Therefore, orbit is also called stationary state or stationary level or energy level. You got my point? Okay, next point. You are connecting to angular momentum. Okay, when electron is revolving in the circular orbit, angular momentum of the electron is quantized. Angular momentum of the electron revolving in the orbit is quantized. See, whatever the point you are going to explain, it should connect to the orbit only. Okay. Angular momentum of the electron revolving in the orbit is quantized. MVR is equals to integral multiple of h by 2 pi, where n is the orbit, that means integer value. First orbit, second orbit, third orbit, fourth orbit, goes on, right? That is angular momentum in the orbit. Next, as number of orbits increases, size of the orbit increases, that means radius increases, energy also increases, that is energy is nothing but orbit energy or electron energy, both are same. Okay, so energy also increases, but energy difference between successive orbits decreases. Okay, and velocity of the electron also decreases. Velocity of the electron in the first orbit is greater than velocity of the electron in the second orbit. It is greater than velocity of the electron in the third orbit. Okay, so up to this. Next point is Bohr's theory, that is Niels Bohr proposed equations to calculate size, means radius of orbit, and to calculate energy of electron in the orbit. Okay, nth orbit. Okay, and the basic point we should remember that Bohr's theory explains the spectrum of one electron containing species like hydrogen atom or helium plus or lithium 2 plus or beryllium 3 plus. Okay, we should, Bohr's theory, Niels Bohr means it is connecting to that. Okay, so now coming to the next point after this. Niels Bohr equation, or you can say expression, to calculate radius of the orbit. Bohr's equation to calculate radius of the orbit. Okay. Bohr's equation to calculate radius. Yes. Radius of nth orbit is equals to n square h square by 4 pi square m ze square. Okay, Bohr's equation to calculate radius of nth orbit of species containing one electron only. Okay, that is applicable to hydrogen atom and helium ion. Okay, here I will write hydrogen atom, helium ion, lithium 2 plus and beryllium 3 plus. So that is one electron containing species like this. Okay, that is Bohr's equation to calculate radius of one electron containing species. Next, Bohr's equation to calculate energy of the electron in the nth orbit, that is equals to minus 2 pi square m z square e to the power 4 by n square and h square. Okay, this is Bohr's equation to calculate energy of the electron. Bohr's equation to calculate or to determine radius of the orbit. Okay, this represents radius and this represents energy of the electron in the nth orbit of species containing one electron. You got it? So this is some important points of principal quantum number. Okay, so we can also say like one Bohr-Bury principle is also mentioned, the maximum number of electrons present in an orbit, that is equals to 2n square. Okay, 2n square. Okay, so based on this orbit we can say it is 2n square. For example, in fourth orbit, that is n is equals to 4, how many electrons are present in that? Sir, it is equals to 2 into 4 square, that is equals to 2 into 4 square, 16, that is equals to 32 electrons. Explain why it is 32 electrons. Okay, based on this we can give this formula and we can explain that 32 electrons. Explain how the 32 electrons, it is difficult for you people. So that is why we'll discuss this principal significance at the end. Okay, So just for the information sake only I am giving, it is 2n square. Okay, why it is 2n square? Slowly we can learn. That is, after this principal quantum number we have azimuthal quantum number, magnetic quantum number, then spin quantum number. Okay, so after that magnetic quantum number you came to understand that why it is 2n square, right? Okay, now it is principal quantum number is done. Okay, next one is azimuthal quantum number. Yes, principal quantum number. Once again let us see the review of principal quantum number. Okay, that is short revision. Principal quantum number was explained by Niels Bohr. Principal quantum number represents the circular orbit in which electron revolves around the nucleus. Right, next point. Principal quantum number represents orbit. It is denoted by n, small letter n. Next, the number of orbits n are designated as n is equals to 1, 2, 3, 4, 5, so on, or k, l, m, n, o, p, so on. That means number of orbits are designated like this. Next, as long as electron is revolving in the circular orbit, energy of the electron remains constant. Therefore, orbit is also called stationary state or stationary level or energy level. Got it? Next point. Angular momentum of the electron in the orbit is quantized. mvr is equals to nh by 2 pi, where n is integer that indicates orbit. Okay, got it. Next, as the number of orbits increases, size, that means radius of the orbit increases. Okay, energy of the electron also increases, right? But energy difference between successive orbits gradually decreases. Got it? Energy difference between successive orbits gradually decreases. Velocity of the electron also decreases. Is it clear to all of you? Yes, as the number of orbits increases, size increases, that means radius increases, but energy difference between successive orbits gradually decreases. Velocity of the electron also decreases. Okay, right. Now, Bohr equation to calculate radius of the orbit and Bohr equation to calculate energy of the electron in the orbit of species containing one electron. Okay, is it clear? So, principal quantum number to some extent is we completed. Okay, now let us take up the next one is azimuthal quantum number. Okay, azimuthal quantum number. Second quantum number is azimuthal quantum number. Let us write number 2, azimuthal quantum number. Azimuthal quantum number. Yes, azimuthal quantum number was explained by Sommerfeld. Explain azimuthal quantum number. Okay, so Sommerfeld introduced elliptical suborbits. To explain angular momentum of the electron. Sommerfeld introduced elliptical orbits to explain angular momentum of electron. Got it? To explain angular momentum of electron. Again I repeat, listen. Sommerfeld, by introducing elliptical orbits, he explained angular momentum of the electron, okay, in elliptical orbits. Okay, now in elliptical orbits, the nucleus found at the center, at the foci of the major axis. Okay, in elliptical orbit, the nucleus is found at the foci of the major axis. It may be left side or it may be right hand side. So the angle made by the electron in the elliptical orbit, that is called azimuthal angle. To explain azimuthal angle of electron in the elliptical orbit, Sommerfeld discovered a new quantum number that is called azimuthal quantum number. Okay, this azimuthal quantum number is also called angular momentum quantum number. It is also called angular momentum quantum number because to explain angular momentum of the electron, he introduced elliptical orbits. Okay, that is why azimuthal quantum number is also called angular momentum quantum number. You got it? Now, this azimuthal quantum number is denoted by the symbol L. Okay, azimuthal quantum number denoted by L. Okay, this represents, that means azimuthal quantum number, that means Sommerfeld represents, okay, existing of elliptical suborbits in addition to the circular suborbits. I repeat, Sommerfeld explained azimuthal quantum number. Okay, according to Sommerfeld, what does it explains? That is, it explains, azimuthal quantum number explains, or Sommerfeld explains, existing of elliptical suborbits in addition to the circular suborbits in a given energy level. Okay, that means that is the introduction of this azimuthal quantum number. Azimuthal quantum number signifies to explain existing of elliptical suborbits. Remember, it is suborbit. Okay, suborbit. Okay, in addition to the circular suborbit in a given energy level, that means orbit. Okay, so the continuation of this azimuthal quantum number, okay, because it is only the just introduction to the azimuthal quantum number. We started introduction to the azimuthal quantum number. The details of azimuthal quantum number, okay, we'll continue in the next session. Okay.